Hello my dear students, welcome to my class. I think all of you are good in health. Today we will start another new chapter of class 11 mathematics, and the chapter name is complex numbers and quadratic equations. Okay, so in previous classes you have studied real numbers, irrational numbers, integers, etc. But in class 11 another new numbers comes up, and the numbers are complex numbers. Okay, now see the basic chart or basic concept of numbers. Listen students, if we write plus 1 plus 2 up to plus infinity, then these numbers are called natural number. Okay, and natural number denoted by capital N. After that, if we include 0 with this number, then these numbers are called whole number, and whole number denoted by capital W. After that, if we take the negative number also, that's mean minus 1, minus 2, minus 3 up to minus infinity, then these numbers are called integer, and an integer denoted by capital Z or capital I. Okay, next rational number, that's mean P by Q form, where Q not equals to 0. Okay, and the rational numbers denoted by capital Q. After that, separately irrational numbers, that's mean root 2, root 3, etc. Okay, these are the irrational numbers. Clear? Now real numbers contain both rational and irrational numbers, and real numbers denoted by capital R. After that, last one is complex number, and complex number is of the form a plus I into b, or x plus iy. As for example, if we write 2 plus 3i, then in complex number, this is the graph, because complex number contains all real numbers and the numbers which of the form a plus ib, and complex number denoted by capital C. Clear? So first one is natural number, next whole numbers, next integer, after that rational numbers, and separately irrational numbers. Real number contains both rational and irrational. Okay, and after that final one is, that's mean last one is complex number, which contains the real numbers and the numbers which of the form or is of the form 2 plus 3i or a plus ib or x plus iy. Okay, so last one is complex number, and this is your chapter, or this is your topic, complex number. Clear? Now see this diagram. First one is natural numbers, 2, 4 by 4, that's mean 1, 8, and why root 9? Because root 9 equals to 3. Next, if we include 0, then whole numbers. Next, if we take the negative numbers also, that's mean minus 2, minus 1000, minus 8, minus 4 by 4, that's mean minus 1, then this is integers. Clear? And next rational numbers. Rational number is of the form p by q, where p and q are integers and q not equals to 0. Next, separately irrational numbers. So real numbers contains both rational and irrational numbers, and the last one is complex number. Okay, so complex number contains the all real numbers and the numbers which are of the form a plus ib. Clear? Now students, that's mean all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. Okay, after that real numbers contain both rational and irrational numbers, and all real numbers are complex numbers, but the converse part is not true. Okay, all real numbers are complex numbers, but all complex numbers are not real numbers. Is it clear? So students, I already told you all complex number are in the form a plus ib. So why all real numbers are complex number? Tell me. Because real numbers are not in the form of a plus ib. But I told you all real numbers are complex numbers. So why? So because, so here is 3. 3 is a real numbers. So 3 can be written as 3 equal to 3 plus I into 0. Clear? Because 3 can be written as in the form of 3 plus I into 0. So this is a plus ib from here. A equals to 3 and b equals to 0. And here is 5i. Again 5i can be written as 0 plus 5i. So this is again a plus iv form, where a equals to 0 and b equals to 5. Clear? That's why all real numbers are complex number. Clear? So all numbers, okay, so all numbers are complex number. Clear? Now definition of complex numbers. Okay, let us denote under root of minus 1 by the symbol I. That's mean I equal to under root of minus 1. Then we have I square equal to minus 1. This means that I is a solution of the equation x square plus 1 equals to 0. So a number of the form a plus ib, where a and b are real numbers, is defined to be a complex numbers. Clear? A number of the form a plus ib, where a and b are real numbers, is defined to be a complex number. For example, 2 plus i3, minus 1 plus I root 3, and 4 plus I into minus 1 by 11 are complex number, because all of this number is of the form a plus ib. For complex numbers denoted by, so complex number denoted by z. So for complex number, z equal to a plus ib. A is called real part, and that's why denoted by real z. Okay, real part denoted by rez. Okay, and b is called imaginary part denoted by imz, imz of the complex number z. For example, if z equal to 2 plus i5, then rez equal to 2, and imaginary part, that's mean imz equals to 5. Okay. Next, two complex number z1 equals to a plus ib and z2 equals to c plus id. If two complex number z1 and z2 are equal, then real part equal to real part and imaginary part equal to imaginary part. So here z1 equal to a plus ib and z2 equal to c plus id. So re z1, that's mean a, and re z2, that's mean c. So a equal to c. Again im z, okay, I am z1 equals to ib, and I am im z2, that's mean id. So ib equals to id, I cancel, so b equals to d. Clear? So if two complex numbers are equal, then real part equals to real part and imaginary part equals to imaginary part. Is it clear? Now students, if we write z be a complex number, or let z be a complex number. Okay, then z can be written as z equal to a plus ib, or c plus id, or x plus iy. Okay, you can write any of these three form. Okay, or you can write a1 plus ib1, no problem. Okay, so for this here a comma b are real numbers. Okay, for this c comma d are real numbers. Here x comma y are real numbers, and last one is here a1 comma b1 are real numbers. Okay, that's mean if z be a complex number, then z can be written as a1 plus ib1, or a plus ib, c plus id, x plus iy, no problem, you can write any of this form. Okay, again suppose let z1 and z2 be two complex numbers. Okay, then we can write z1 equals to, suppose here we take a1 plus I b1, and z2 equals to a2 plus I b2. If two complex number z1 and z2 are equal, that's mean if z1 equals to z2, so implies a1 plus ib1 equals to a2 plus ib2. So if two complex numbers are equal, then real part equals to real part and imaginary part equals to imaginary part. So a1 equals to a2, that's mean re of z1 equals to re of z2, because real part denoted by re, okay, and imaginary part denoted by im. Again imaginary part, that's mean I b1 equals to I b2, so implies b1 equals to b2, or im z1 equals to im z2. Clear? So if two complex numbers are equal, then real part equals to real part and imaginary part equals to imaginary part. Okay, okay, now again let z be a complex number, then z equal to, here we write suppose x plus iy. Okay, so this is a real part. Okay, and denoted by re of z equals to x, and this is imaginary part. Imaginary part denoted by im z equals to y. Okay, so this is the real part and this is the imaginary part. Real part denoted by re of z and imaginary part denoted by im z. Okay, now students, we solve this problem. Example 1, if 4x plus I into thrice x minus y equal to 3 plus I into minus 6, where x and y are real numbers, then find the values of x and y. So student, see that here in left hand side 4x plus I into thrice x minus y. That's mean this is a plus ib form. That's mean this is a complex number, and in right hand side 3 plus I into minus 6, this is also a plus ib form. That's mean left hand side is a complex number and right hand side is also a complex number. That's mean here two complex numbers are equal. Okay, so we can easily find the values of x and y by equating the real and imaginary part. So the solution, we have 4x plus I into thrice x minus y equal to 3 plus I into minus 6. So here two complex numbers are equal, so real part equal to real part and imaginary part equal to imaginary part. Okay, so 4x equal to 3, so 4x equal to 3, and I into thrice x minus y equal to I into minus 6, so I cancel, so thrice x minus y equal to minus 6. Okay, so from this 4x equal to 3, so x equal to 3 by 4. If we put x equal to 3 by 4 in this thrice x minus y equal to minus 6, that's mean implies 3 into 3 by 4 minus y equal to minus 6, so implies minus y equal to minus 6 minus 9 by 4. If we take LCM 4, that's mean minus 24 minus 9 divided by 4, so equal to minus 33 divided by 4. So minus y equal to minus 33 divided by 4, so y equal to 33 divided by 4. Okay, so finally we get x equal to 3 by 4 and y equals to 33 by 4. Okay student, everything is clear. So okay students, now today's session is complete. I think this class was helpful to you and you have understand the things. If you have any queries, then you can ask me. Okay, thank you students. Bye, stay safe, stay at home.